Hello, ladies and gentlemen, and welcome to my let's study in physics. Yes, physics. We're gonna do some projectile motion. It's going to be fun. Let's go. I got my scientific calculator ready. Uh, Ready that bad boy up. There you go. It is on. It's turned on. Got my mechanical pencil. I've got my rubber, and it's off to do some calculations. So I got my formula sheet ready to uh, do whatever the formula sheet does, and we will continue. Let's go. Okay. So, we're recording. Recording. Okay. A car in a diving. Wait, this is in the way. Get out of the way. Am I too small? Am I too small? Okay. Okay. This is good. This is very good. I might have some lipstick on. That's not lipstick. That's lip balm. That's because my lips are dried. Anyways, continuing on. Question 9 out of 18. A car in a diving demonstration is demonstrating its safety features. It'll look really safe. It takes a parabolic path before crashing to the ground. 1.8 seconds later, no one is in the car. What is the initial vertical velocity component of the car? Okay, well, the answer of that would be zero. And I'll tell you why. A parabolic, right? It's going off the cliff. If it was symmetrical like this, like same height, like that, then it would have a vertical velocity, initial vertical velocity, but it doesn't because it's going straight off the cliff parabolically in free fall. Now, the initial velocity at this point, the initial vertical velocity is zero. The initial horizontal velocity is not zero. It has a value, but we may need to find it probably. I don't know. All right, so initial vertical velocity zero. That is the answer. A Vy equals zero. Okay. What is the vertical component of the car's velocity just before it hits the ground? Now that, uh, I think it does have vertical velocity. Okie dokie. Let's use the formula. Okay, what are we given? Seconds, given time. We are given time. Initial vertical velocity, zero. Time, 1.8. And it's vertical, right? Vertical. What's the acceleration uh, in a vertical component? Gravity, yes. Yes, acceleration due to gravity. Now we're going to do that. So the formula is V equals U plus GT, where U is the initial vertical velocity, that is zero. V is the final velocity that we're trying to find. And G, is the 9.8 meters per second squared. T is time. Now, 1.8 times 9.8. That gave me 17.64 meters per second. I don't know if that's correct. Probably. I mean, that's probably. Okay, so V, Y, equals 17.64 meters per second. Right here, on to question C. What is the vertical distance that the car falls through? Okay, now we're going to use a different formula. Now, a different formula would be, I'm finding distance, right? Vertical distance. So we could use uh, S equals UT plus 1 over 2 AT squared, right? Where U is the initial velocity, which is 0, so 0 times T is 0, plus 1 over 2 A, G, 9.8, times T is the total time it hits the ground. So we'll use that. So 9.8 times 1.8 squared, divide that by 2, and that gave me a distance, a vertical distance of of 15.88, or we could just say 16 meters. We could say 16 meters. Now let's see. Okay, so they do it in no decimal places. Okay. So 24A. Wait, 24, what is 24? Question 9. Anyways, question A. 0, it is traveling horizontally. Yeah, that's probably more better to say. 18 meters per second. I got 17.64, rounded to the nearest whole number, 18, yes. And 16 meters. Yes, that is correct. Good job, guys. You are doing amazing. Oh, oh damn, this looks hard. A ball flies through the air following the path shown in the diagram. Okay. Now we're given something else. Okay, so the ball's mass is 450 grams. Its initial kinetic energy is 110 joules. The initial angle is theta and maximum height is h. So that'll be the turning point. And at the turning point is when Vy equals 0. But Vx, the horizontal velocity, does not change. It is always fixed, always constant. But Vy is always dependent on gravity. So it has an acceleration, so velocity can differ, can vary. However, Vx is the same since there is no acceleration. It's constant. What is the speed of the ball at the start of its flight? So the speed of the ball we're looking at here. We're looking at this speed, tangent to the path, that speed right there. Now that speed, in order to get that speed, we need Vx or Vy. Or actually, it's giving us kinetic energy. So we can use the formula kinetic energy equals 1 over 2 mv squared. Or if I had a, pretty sure Zoom offers a whiteboard, but I don't know if it's going to be helpful. Because I want this to be a beneficial study session for you guys too, but I don't know. Oh wait, I can have paint. Uh, paint, paint. Yes. Can I put you on the side? Wait, can I do this? What am I doing? Uh, I've got a big head. What do I undo? Control Z. Control Z. What do I redo? Control Y. Gotcha. I gotcha. Okay, let's do this. So we're using the formula E kinetic energy. Wow, I'm terrible drawing on the computer. So E K equals 1 over 2 M V V squared. I think, yeah, a mouse would have been really helpful by now. All right, so we're given the mass, but this time, listen, M is in kilograms. So converted to kilograms. Joules, it's in joules. That's simple. So we just rearrange and make V the subject. So V can equal uh, uh, square root. I'm gonna do this in one go. Watch me do this in one go. Two uh energy, energy. Oh my God. Um, divided by M. This M is included with the square root, of course, mass. Okay, now we just sub the values in the corresponding equation. Yep, okay, I did it right. All right, so 110 times that by 2. Yes. Now we divide it by what? Yes, 0.55 kilograms. You are correct. Now we square root it, and we got 20 meters per second. Have I done this question before? I cannot remember. So at 10, uh, question A equals 20. No, question A. Speed, speed equals 20 meters per second. Okay. And question B, if height equals 8 meters, calculate the kinetic energy of the ball at maximum height. At maximum height. So what do we need to use? The con. Wait, are you going to say it? Yes, you are correct. The conservation of energy. You're going to use that. I feel like a crazy person. I'm trying to act like a YouTuber, but I don't think I am. Um, okay. So conservation of energy. So MGH in this case. Um, is- there is no MGH there. It's just kinetic. So it's EK initial equals MGH plus EK. Okay, all right. So there has to be a better way of writing this. EK initial. Oh my God. What? All right, that equals. Now we're using the conservation of momentum formula. So kinetic energy initial. So this is the kinetic energy initial here. Now kinetic the energy final, which is would be here, is mgh, um, which is E gravitational energy, potential energy. Probably better to say G gravitational whatever plus EK, which is the EK that we're looking for. So oh my God, this is killing my arm. Oh my God. Okay. Anyways, let's find EG. Now the formula for EG is mgh. Now the formula for EG is mgh. But can I say that that we can divide m from both sides of the equation? Because there's an m here, there's an m here, there's an m here. So we divide m, so m becomes irrelevant. So I can say GH, which is 9.8, times it by, what are we given? 8. Times it by 8 meters. Now, the energy, the energy of the potential component is 78.4 joules. All right. So this equals to 78. Oh, um, oh my God, I'm terrible. Let's just say 78 joules. All right, whatever. 78 joules. Oh my God. Um, and then we know what EK initial is. That's 110. Says it right there. So 110 minus 78.4. Now the energy Oh wait, we already found it. All right, so the energy final is equals 31.6. What unit of measurement? Joules. Yes, correct. Correct. Good job. Now, next question. Calculate the speed of the ball at maximum height. Now, we're given the energy. Now we're going to use the formula 1 over 2 mv squared. Now we do need to use m. M is relevant, I believe. So 31.6 times that by 2, and then divide it by, what's the mass? Yes, 0.55 kilograms. You are correct. Now, square rooted. And we got velocity 10.7 meters per second. That is correct. I think. I don't know, probably. Now calculate the angle theta. Hmm. Now, so given we did all of this, but can I say the speed at maximum height, Vy equals 0, so Vx has to equal 10.7. Yes, because that's the only component left. 10.7. So we know that the Vx equals 10.7. Correct. Now, but what is Vy? But that's the thing. If we know the speed of the ball at the start of its flight, at the initial, did I calculate that? Was it 20? Equals 20, all right, 20. What I can do, I could use trigonometric formulas. So I could say adjacent of a hypotenuse, so inverse cos inverse, adjacent, which is 10.7. Divide that by a hypotenuse, which is 20. Hopefully, I got 57.7. 57.7 degrees. No, I didn't get it. Wait, 20 meters per second, yes. 60. What? What? No, impossible. This is impossible. Now it's 30. Now it's 30. It's because I got this wrong. 25B. I got 20. Maybe I did it too fast. Oh, wait. Oh, wait. I'm such an idiot. What am I? Yeah, 70 point. Doesn't make any sense. 67 joules? No, it's not 60. It's not 67. Difference? It's the difference between 110 joules, yeah, and GP at maximum. Yeah, that's what I did. 110 joules minus GP minus gravitational energy, potential energy. I don't get it. Oh, wait. Did they times it? Oh my God, wait a second. Because if I do divide both sides by m, then I won't get 110 joules. It'll be something else. Ooh, that is my bad. You cannot divide both sides by m. I made a big mistake. Ooh. Okay. Now, we all make mistakes. I wrote my mistake. Now, it's 67 joules because you don't divide both sides by m. You only do that if you're calculating a certain variable. What we're calculating is just joules, and it's given in a simplified form such as this. Now, all we have to do is just use the formulas. Don't configure it, don't change it, just let it stay as it is and calculate from there. So 110 minus 43.12 gives you 66.88, or we could say 67 joules. Now we put 67 joules. 67 joules. That Yeah, so 67 joules is the kinetic energy. So 67 times 2, divide that by 0.55, square root that, and I got 15.6. Yeah. Okay. Oh, 15.6 meters per second. Okie dokie. Now, now we can use that tan theta. So, adjacent is actually, so inverse cos adjacent, which is 15.6, divide that by the hypotenuse, which is 20 meters per second. Now, I got 38.7. Oh, 38.9. Okay. No, just 39. Yep. Uh, D theta equals 39 degrees. So, very nice, very nice, very nice. How do I undo, undo? How do I undo? This is very, okay, whatever. Just, okay. Anyways, wow, this one looks really complicated. I haven't done this one. This is 2015 exam essay from South Australia. A golfer hits a ball on a part of a golf course that is sloping downwards away from him, as shown in the diagram. Wow, now this one is one of the complicated questions that you have a uh, perfect symmetry of a inverse parabola, and you also have that little bit of distance right there. Now that is a bit difficult, right? Makes life more harder for us. But luckily, we were given the total horizontal distance, 173 meters, 30 degrees, 40 meters per second. A lot of information, nice. The golfer hits the ball at a speed of 40 meters per second at an angle of 30 degrees to the horizontal. Ignore air resistance. Calculate the maximum height that the ball rises before its initial position. Calculate the maximum height, h, the ball rises above its initial. Okay, so calculating h. H is the maximum distance that it can reach before um, going down due to gravity. Now, what do we do? Now we know that at the turning point, Vy equals 0. So we're going to use Vy as because that's the vertical component, and the H is distance is horizontal, vertical. Sorry. All right, so let's do this. Now, which formula should we use? We can find the initial vertical speed components by using trigonometry. So, opposite over hypotenuse. So 40 times sine 30 degrees. Now I got 20 meters per second. Got 20 meters per second. Now, let's use the formula. Um, okay. Yeah. Okay. It's already derived for us technically. The Okay, the form. What is going on? What have I done? I just want to draw. Brush. I don't want to brush. I want a pen. What have I done? Okay, I hate paint. Never using it again. Actually, that's why I'm probably gonna use it again. Um. Okay, let's do this. Let's do this, man. Okay, so we got the vertical component, vertical speed component initially, which is 20 meters per second. That's initial. Now we're going to use the formula v squared equals u squared plus 2as. Oh my God, how long have I been doing this? It's been like 30 minutes. All right, I think this will be the last question for us. And yeah, will be the last question. Um, v squared, the final, 0, u squared, that's what we have. Finding the height. So u squared, 20 squared. And I get this. Actually, oh, my bad. 20 squared, it's 400. Now, 9.8 times 2. Now, 400, divide that by that, 19.6, gives you 20. Oh, so that should be it. Yep. So the height should be, that's a 2 mark question. Height equals 20 points. Gosh, no, what's wrong with this thing? Oh, do you have any more left? Didn't you? Oh, you did. Okay. All right. So 20.4 meters. There we go. Put that in the bin. No, put you in the bin. And you're too thin. I didn't put you in. I missed. Okie dokie. All right, let's do this. So I got 20.4 meters. Yes, that is what I got. Now let's move on to question B. The ball lands a horizontal distance of 173 meters from the hitting off point, as shown in the diagram. Now calculate the vertical drop D. This is the vertical drop D from the hitting off point to the landing point G. Wow, okay. That's actually, I don't think I've done that before. So it's giving you 173 minutes, so we probably have to use that somehow. Hmm, well, that is a good question. It's requires a lot of thinking. I guess that's 3 marks as well. That's a big question. Hmm, if we're given time total, if we have the total time, does total time have to do with anything? If we can find the time for, if we can find the time from here to here, then what could we use? Could use S equals UT, but UT, initial, but it's symmetry. So the speed at there should also be 40 meters per second, but we're doing vertical. So vertical should be the same. It should be 20 meters per second. Okay. But our main problem is T. I think that's the problem. Okay. 173 meters. We're gonna use that. They've given that to us, so we're gonna use it. So, horizontal distance equals the horizontal speed times the total time. The total time. Okay. So we are going to utilize that. So, let's find the horizontal speed. So that is by using trigonometry. Trigonometry, yep. Adjacent over hypotenuse. So 40 cos 30 degrees. That gave me 34.64 meters per second horizontally. Now, let's use the formula 173 divided by that. I got approximately 5 seconds. 5 seconds total time from there to reach the G landing spot, landing point G. Now, if we can find the time from here to here, which we can, um, let's just sorry say total time. T top equals 5. Now, um, okay, initial. No, we want to use that. Wait, the final zero initial. Okay, so initially the vertical is 20. 20, divide that by 9.8. So I got a time of 2 seconds. 2 seconds is from here to here. Now from here to here, you got to times it by 2 because it's in perfect symmetry. Now I got 4.8.08 seconds or 4.1 seconds, as you can, if you will. Um, so I could say 5 minus 4.08 or 0.92 seconds, 0.92 seconds. Or if I want to be more accurately, because it technically said 4.99 minus, it's technically, oh, it's actually less. Yeah, all right, 0.91. All right, 0.91 seconds technically. Um, so we use that, and we're going to use the formula derived from one of the linear accelerations. Mm, so T total, I mean time, that now we have is 0.91. So that 0.91 seconds is from here to here. Now we have it now. So now that equals the square root of 2 times the distance, the vertical distance, divided by 9.8 gravity. Now, let's square that, get rid of the square root. Let's times that by 9.8 gravity, and we'll divide it by 2. Now, I got 4.08 meters. Now, I hope that's right. Wow, I was way off. My goodness. 23 meters? What? Hmm. Then use S equals, you want to use that? I mean, well, that's the total distance, isn't it? Wait, no, is it? Is that total? I'm so confused. What was it looking for? But that 5 seconds, that's T total, isn't it? S equals UT, but UT is 20 times. So if you do 20 times 5 and 5 squared times by 9.8 divided by 2. So this minus that gives you 24. Hmm. I'm a bit skeptical because I cannot really understand. 5 seconds is the total time. So that total time's from here to here. All right, well, that concludes our let's study for physics. I'm still confused. I understand this. That's the speed, the horizontal speed divided by. No, that's not correct. No, they did it the wrong way. That was by accident. They did it's 173 divided by that. Then they used that, but 23 meters. I mean, I guess it doesn't make sense though. 23 meters. Man, I gotta ask this question to the teacher because I'm a bit fumbled right now. T from the horizontal, calculate T from horizontal motion, yeah. What is this T though? This T is the total time though. Didn't I write this down somewhere? Where T is total time? Yeah, T total. Well, that's just one of the many questions that we have to ask ourselves. It's been quite a long time, and I've only done what, 3 questions? From here to 9, 10, and 11. Wow, fascinating. The next question. Wow, it's another one. Have we done this question before? What kind of formula is this? Even 41? This formula is derived from somewhere. I should probably put them by reference, actually. But where, um, okay, that's actually a good formula to use. R, why R? Can I just say D? Oh, wait, um, D equals, D equals V squared sine 2 theta. Divide that by 9.8. That's for horizontal projectile motion. Let's say projectile. Proj, projectile, horizontal. Oh God, I'm wasting so much paper. All right, projectile horizontal. Oh my God, there's still so many questions. There's still so many questions. Oh my God, there's so many questions. Oh my God, there's so many questions. All right, you know what? I'm done. I'm done. It's nine. What time? 9:30. Oh my God. It's not too late, and tomorrow's the weekend. But I cannot be stuffed. My brain hurts. After doing three questions, it's crazy, man. I usually do more than three questions. Anyways, um, how do um, how do I just stop? Okay, just stop sharing. Okay, all right. I'm recording still. Okay. Well, that was a very good and fun Let's Study session for physics. Amazing, quite spectacular. Yeah. Um. So if anyone got inspired from physics because of this, then you're welcome. You are welcome. And that's it. Don't steal my formula sheet. This is my formula sheet. That's it. All right. I'll see you guys in my next study session, part two, which will be about chemistry. It will be about chemistry. Yes, we are going to do more science. Okay. I appreciate you watching me till the end of my study session. I will see you guys in my next part. Bye bye. How do I end it? Oh, wait, what's this?